computer. Spell check. That's awesome. No one's ever gotten that. Okay, last one. What did Dracula get when he bit the abominable snowman? Frostbite. Good job. That's awesome. Okay, so today I am battling a cold and my voice is going out. So hopefully I don't sit here and cough all through this. I'm going to try not to, but I can't promise anything. And hopefully my voice actually holds out through this and my next lecture. Okay, so starting something new here today, kind of moving on. So today we're just kind of understanding the hierarchical file system. And again, some more fundamental commands. I told you before, kind of the cart before the horse. Some of these commands we've used several times. This is kind of just your official documentation. So on those things, we'll probably just glance over it and just kind of concentrate on the new stuff. We will not make it all the way through on this one as we start to hit file permissions. So when I get to file permissions, because that is kind of like this moment of major shock, I really need to split it up into a different lecture anyway. We'll stop there and then we'll come back Thursday and cover nothing but file permissions. But just be warned, a lot of people struggle when we hit file permissions. It's a lot of information if you've never kind of played around with Linux file permissions there. Okay, so once again, an example of that hierarchical file system. And of course, as we know, everything kind of starts right here at the root right there. And then we have this home directory, which isn't our home. It's just called home, which then has all of the users' home directory in there. So in this case, Mike would own all of these files here, and then Jenna would own all of these files here. And I have no idea why I did the dots right there, but oh well. All right, so some things to understand. One, when it comes to file names, there's some things that we need to avoid and some things we need to kind of do here. So uppercase letters, that's good. Lowercase letters, that is fine. Numbers is fine. Underscores is fine. Dashes, you can, but you have to be very, very careful. Only use dashes like in between file names. Don't start with the dash because anybody remember what does dash represent in Linux so far? Option. So that's what it's actually going to be expecting. So if you start a file with the dash, it's thinking, hey, this is some type of option. So in order to actually prevent that, you have to do dash dash in front of that file name that starts with the dash. Dash dash tells this is the end of option. So you'd actually have to kind of precede that. So that's just an extra step. We don't want to have to do that, especially when we start writing scripts and we don't know what files will run into. So it's best to just avoid. This is a very bad practice. So if someone does that and you write a script and you don't actually code for that, then you could be in trouble. What you got?
I've seen some programs where one of the options is dash dash help. Is that a file?
Dash dash help is a command. It's kind of like this default thing. If you were coding your own help into the actual program that you write, it's just kind of like the default way of getting quick help right there. So it's normally programmed into the actual command. It's not like something separate, like the man is a separate file, it's just a man file with that help information, but it's normally just a small condensed help.
Also, is this third-party open?
It's supposed to be, but I just got here, showed up, so it wouldn't be surprised if I didn't open it up. Yeah, here we go. Make a note. Good job. Y'all keep me on my toes on that kind of stuff. I've actually been doing pretty good on recording stuff this semester. All right, so periods, it's obviously not advisable to use a period within that because, well, I mean, what's a period normally used for in a file name? An extension, right? But as we'll see here in a little bit, a period actually has a special meaning in front of a command that is hidden file. So if you precede it with a period, the file will not be visible by default. And then of course, comma is not advisable. And a lot of this stuff also goes back on compatibility. You know, as we all know, Windows, it doesn't like commas sometimes. And of course, the dot is, you know, a file extension that actually has meaning in Windows versus Linux here. And then avoid spaces. And the reason why you want to avoid spaces is because when we have arguments on the command line, so if we do a command and then we type in an argument, so if we were creating a directory, let's just do that. We created a directory and then we typed maybe a sentence out. And of course, the sentence is all broken up with spaces in between it. It's going to think that each single one of those is an actual argument in of itself. So we would have, if we wanted to create a directory that actually had spaces in it, we'd have to put it in quotes. So the same thing happens when you're trying to reference that later. If somebody writes a file name that has spaces in it, it will think it's separate. So you'd have to put it in single or double quotes so it knows. So that's just extra work. So we try not to put any file names with spaces in Linux. So the best case would probably use underscores, dashes, or camel case with your file names. Of course, we've already talked about this. The part of the file name that follows an embedded period is going to be an extension. Of course, they're optional in Linux. It just helps describe the contents. The actual file type is specified by the data that is inside the file. So a file name that begins with a period, that is, again, that's that hidden file. So if we want to hide a file, it'll have a period. If we get into our systems here, and we haven't covered this command right here, but if we do a normal ls, these are all normal files, but there's actually some more files in there. If we did ls-a, hit enter, then you can start seeing there's a lot of files in here that actually have a dot in front of it. So A is going to get us all of those hidden files there. And of course, it's a little bit better. I like seeing a little bit better in the long format where you get the additional information. They're all kind of in order, and all the periods are the first ones that are in there. All right, so there's also some more special meanings to the period. So when you look in your directory like we just did, right here, I'll make it a little bit larger. You see these two files. You got this one right here, and then this one right here. So this period right here, that represents the current directory that we're in. So that way, when we run this long listing on it, we can actually see the file permissions of the directory that we're currently inside. So you can see that I own this directory right here, and then we'll talk about permissions next time, but that's the permissions on it right there. And then what do y'all think ... represents? The what? The parent directory. Perfect. So as you can see, the parent directory of this would be /home, and root is the owner of that. So you can see that's why that is different right there. Root owns that parent directory. So that's kind of two more special meanings for the periods right there. And then I just kind of have some information. PWD, of course, gets us that path so we can see where we're at. And then I told you kind of the difference with Ubuntu /home, and then the username is your home directory, while Mac OS, it'll be /users, and then the username for the home directories there. Okay, some more definitions. So a file name is just a sequence of characters other than slashes. If it's slashes, that's going to change that meaning. So in here, we have foo being circled. So foo is a file name, .profile is a file name, and then we have df. Now, a path name is actually going to have those /slashes in it. So in this example, if foo is what we're kind of referencing right here, then the full path to foo would be / and then temp / and then foo. So we would get this right here. That would be the full path name to foo right there. All right, the working directory. So if we were CD'd into Jane right here, then our working directory or our present working directory, those are interchangeable. That would be Jane right there. And that plays a major part, especially when we start writing in our scripts. We'll kind of learn that as we go, what importance that plays. Now, startup files. There are several startup files. These are, see, .bashrc is a startup file. We'll talk about that later on. .profile is a startup file. This is the message of the day that's shown once a day. That's kind of a startup file. There's many, many, many more. And depending on the flavor of Linux that you are using and the actual shell, all of these can change. Of course, .profile is pretty common. There's some others right there, but like the bashrc, that is very specific to the bash shell. So if you're running ZSH, you would probably have some ZSH version of that bashrc there. Okay, this is a major part that you need to understand. It becomes very, very important later on when we start writing scripts, and that is the difference between a relative and an absolute. So an absolute path name starts at the root of the directory and then is completely specified. So in this example right here of .profile, if we wanted to know the absolute path of .profile, then we would specify it as /, and then we would say home / Jane / and then end in .profile. So that is our example right there of an absolute path name. Now contrast that with relative path names. So relative path names always depend on whatever your present working directory is. So it's always based off of your current location. So that same file, if we are CD'd into Jane right here, then actually we'll start right here because that one's a little bit easier. We'll say that we're CD'd into / right here. No, let me understand where I'm going. So we'll stay in Jane right here, but we're referencing, we'll do foo right here. So in order to get to foo, which is this one right here, we would have to say cd ... So then we're in home right here. And then we do cd ... again, which gets us up to the actual root of the drive. And then because the temp is the actual child of /, then all we have to do is reference temp /. And then from there, foo is a child of it. So we can just say foo. Versus if we wanted to, if we were CD'd into Jane right here and we just wanted to reference .profile, we could simply type the word .profile and that's it. Now, what do y'all think about this right here? Why, if we're CD'd into Jane, how's this path work? Why am I typing what I'm typing there? Can anybody take a guess? Let you go.
No, I was just gonna say, you're already in the Jane directory or a single dot. Did you say that that refers to your current working directory?
Perfect.
So you're in your current working directory / .profile.
Perfect. That's it. So this right here is just kind of fully specified, but we don't have to do that. We can shortcut it by just saying .profile. And this part is just understood right there. You don't have to specify it. It throws a lot of people off when they first see it. So don't let it throw you off. Some people like to code like that. They're very specific in how they do that. But no, and then we're going to expand on this whole dot right here. Dot is actually a command by itself as well. So it gets really, really fun in Linux when we start seeing all the how similar things are used multiple times, and it just gets worse and worse and worse. I'm sorry to paint that picture for you. All right, so I think we got that. So this gets really, really helpful when you're writing your scripts later on, because let's say you write a script, you have no idea what directory I'm going to put the script in. So when it comes to absolute path, so when you start writing your scripts, your absolute path would be like /home. And then if your name is Jane, it would be Jane. And then you would reference maybe a subdirectory or a file within that. And if you do that in your scripts and then I put it in, or I download it on my computer, what's going to happen? Yeah, I mean, this right here doesn't exist. It would be /J Corcoran for me. And you can't code for all of those different scenarios. So when it comes to writing your scripts, we're going to want to use relative examples right here. And then oftentimes you're not going to care what's above your script. So you're going to give me a script in a directory here. And then all you're going to worry about is what's inside yours. And that stuff is all known. So in this case, if your script was named Jane and you had .profile, from your script, you know that .profile is going to be in the present working directory of Jane. So you can just reference .profile. You don't need to know what's all above this. I could run this, your script, 10 directories deep in my directory right here, and it's going to work every single time, so long as we use those relative path names. I kind of call this stuff hard coding. When you hard code these path names that exist on your, in your system that doesn't exist on mine. And no matter how many times I harp on this, especially, I don't know what it is, but when you do the larger project, I guess because it's so big and there's so many layers to that thing, a lot of people just forget it and then they start hard coding, and then I try to run it and all I get is a whole bunch of errors telling me these files don't exist on the system, because they don't. Or they will start creating files, and that they create those files and they're actually created in their script, but they wind up hard coding or putting in that absolute path, and then it's not even creating that in the script there. So just make sure you understand that and understand the repercussions of those absolute relative paths. And of course, there are some instances like right here, it would be stupid if you were in Jane and you try to reference .profile, you'd be typing way more to use an absolute path. But if you're in Jane and you needed to reference the Etsy directory here, then an absolute path would actually be better. So you didn't have to do this .. And of course, not your script. So again, this is just if you're trying to, CD or edit a file, something there, there's pros and cons to each one. It just depends on the circumstance. Okay, we've talked about this a little bit, but understand files are just a sequence of bytes. There are no file types in Linux. There's only the data, and then kind of like, is this executable or is it not executable? And let's see. Yes, understanding that directories are a list of files and statuses of their files. So everything in Linux is a flat file. And we can kind of prove that right here. So again, we know that if we ran the file command on practice.txt, we can see that's an ASCII text file. We all know that if I remove the extension, it doesn't matter. It's still going to come back as an ASCII text file. If I run the file command on labs here, it's going to say it's a directory, but really this is all a file. We haven't hit this yet, but if I use Vim, it's the editor we'll be using, and I type in labs here and hit enter. This is the actual directory right here. Here is the contents that is in that directory. Those are all those files. So it's just a flat text file. There's nothing that's important to it. It's just listing all the files in that text document. So, don't think on it too hard there. All right, we have seen this over and over, and that's that tilde. So this is a type of expansion that takes place. So that tilde right there is actually expanding to my home directory. So if we did pwd here, you can see home J Corcoran right there. Then if I was to cd into labs, you can see we still have the tilde, which represents this right here, and it'll represent whatever your username is on your system. And again, type pwd, and because I'm in labs, it's going to go ahead and tack labs on. Now, this right here is really nifty to use in your scripts. Why is that? Perfect. It'll work for everybody, right? Because that tilde is going to expand to whatever their home directory could be 10 layers deep. Their home directory could be on an entire different partition or a completely different hard drive. You can set all that up in there. You don't have to know all that. You could simply reference tilde, and then it's just going to expand to whatever the current user's home directory is. So very, very nifty tool. And we can use that. If I said cd tilde, then it's going to expand itself and then put me right back into there. Just so you know, because I do this all the time, tilde is the default on bash. So if I, again, cd'd into labs, I can also just shortcut it with cd and then automatically puts that in there for me and sends me back to my home directory. But that is not true against all shells. So that's kind of just bash specific there. And I'm sure there's some other shells that do it too. I just don't know all the shells out there. Okay, we have seen make directory. So here's just kind of your introduction to that. So you have the options, of course, and then you can specify one directory. You can specify many directories. So again, that's what that ... means. It will support many files. This will support many options or 0 options because it's in the bracket, meaning that it's optional. You can specify an absolute path. So you don't have to be in the actual directory that you're creating that. But of course, in this case right here, it's going to use your present working directory. So it's using a relative path relative to your current, position in the directory. And it's just going to create that. I don't have it on here, but just something that is nifty. If you do a --P and the directories don't exist, he'll go ahead and just create all the directories, even if it's not if they don't, of course, they don't exist. If you specify, like if home and J Corcoran didn't exist, it would create the home and J Corcoran instead of airing out because it only wants to create like one layer of it. So just a side note there. Let's see. CD, we've all used CD right there. No need to spend any time on that. All right. So this right here is remove directory. But note there's a very, very important line right here. Only works on an empty directory. That is kind of the downside to this command right here. because if the directory has contents, it will not remove it. There's absolutely nothing you can do to make it remove it. So let's see how we actually remove directories. And that is, we can use RM. Now, RM by itself will do the exact same thing. It will not remove a directory. It won't remove a directory at all, actually. It doesn't matter if it has contents or not. You can actually give it the -D, and it will mimic rmdir in the fact that the directory has to be empty. But if the directory has contents, we can simply use the -r right there. So that is recursive. Now, be very, very careful with that because it'll do exactly what you tell it to. So if you have a directory with files and there's a subdirectory and there's a subdirectory and a subdirectory, you know, if you run this thing at the root right here and you specify a correct file name, then it'll start removing that, and then it'll hit every subdirectory on it and it will remove it so long as you have permissions. One of the things that they often will tell you to do, especially in a production environment here, this is a good one right here. So if I was wanting to remove all of the temp ones here, and this is more so important once you start learning wildcards, which we haven't hit yet, but I'll just go ahead and show you. So if I was wanting to remove all of those, it'd be better for me to do ls and then specify temp and then the wildcard. And then you can kind of see, why didn't it pick up all of those in there?
Is it just deleting the reference to the directory, or is it wiping the contents?
No, it is just the contents on disk are still there. But like I said, there is no recycling bin. So you would have to run some type of specialized software to recover those files. There is no just built-in way to actually do that. And I'm not sure why that's not picking. Oh, it is. I'm just not looking screen. Yeah, there, it's picking them up. I'm just blind and can't see. So as you can see right here. So if I was wanting to remove all of those, this is how I would do it. But maybe I didn't expect this right here to take place, or, maybe there's a file in here I didn't expect. So it's good to run ls because we can simply up arrow, Control A, delete that, and change it with rm right there. So we're able to kind of test what all the files are going to be deleted before we actually use that rm command right there. And of course, in this case, if I ran it now, it would pick up this one, and then it would error out right here because it is a directory and it has contents in it. So it wouldn't actually delete that. And just kind of show you how we did rmdir right here, and I gave it the temp directory. See, it's failed to remove because the directory is not empty. So if I wanted to remove that, we'll just do this one, which won't work either. It's going to give me kind of similar error there. But if I wanted to actually delete that, since it has contents, we could use rm-r, and then boom, it's successful. We do ls. There is no longer a temp directory right there. So I will be honest with you, I do not use rmdir. It's just another command that I have to memorize. So what's the point? Most of the time when I delete a directory, I'm not going to want to go in and delete all the files and all the subdirectories and their files, and then go back and delete the empty directory. I'm just going to wipe out everything with a single command and use rm-r. Copy command, we've seen that again, that source destination right there. Let's see. Yeah, it also needs that recursive. So if you did a directory right there that had multiple files, it's going to error out saying, hey, there's multiple files. It's not an empty directory. So you'd have to specify the -r. And this right here, I'll never test you over this. This is kind of just some fun information. I like to include it every once in a while. So in this case, I'm making a directory called test folder, and test folder is the argument that was supplied to make directory. And then there is a special key combination of escape plus the period. So just escape period on your keyboard. So if I typed in CD and did escape period, it saves the previous argument to the argument to the previous command. So go ahead and just type that out for you there. All right, this was a bigger deal. We do have it in some of our homework assignments. You'll still need to actually know how to create it. Before we had the Windows Subsystem for Linux version 2, which has a real Linux kernel. We had the WSL1. It was a virtual kernel, and it didn't have the integration. Like we couldn't just browse the directories from Windows. We had to actually come up with a way to transfer to and from Windows. And we did that with links. We would set up a link within Linux that linked to your downloads directory. So then when you move something to that download, you were actually moving it into your Windows downloads directory. But since they've integrated and they're trying to integrate Linux more and more within Windows, now we don't have to do that. But it's still important because you can, one, it's nifty to use this within Linux, and then two, you may see it, and three, it's in the homework, so you'll want to know it. So we create links with the ln command, and there's two different types of those, and that is a symbolic link and then a hard link. The hard link is the old method. It came first, and then we have the symbolic link, which is kind of that new version here, and that's the one that you're going to use more than anything. So it's just a pointer to a file. Think of Windows shortcuts. That's pretty much what this is. There's just two different versions of it. The symbolic link is going to mimic the Windows version more than the hard link is. The hard link, it will only do like a one-to-one mapping. So in other words, you can't use a directory with a hard link. You can only link one file to another file, and that's it. Now, the symbolic link allows you to do the one-to-one as well if you want to do that. But most of the time when you create a shortcut, you're going to want to create that shortcut to an actual directory. So you just click on one link, and then boom, all of your files are kind of in a directory. So it's a lot better to use there. All right, so let's point them out here. So here is an example of that symbolic link and a hard link down at the bottom. So the hard link, what it will do is you kind of have that contents on the disk right there. It will create a direct link to those contents. And then if you create so let's say this is the original file, and then we create our hard link right here, it's going to point directly to that original contents versus the symbolic link. So here is kind of the original file, which points to the original contents. And then we can create a symlink, and the symlink will, instead of pointing kind of to those original contents, it's going to instead point to the file that we currently have, kind of that marker that points to the file. And then of course it points to the contents on there. So again, this is a symbolic link. So ln is kind of the original way to create a hard link. And if you want to create a symbolic link, you just give it that option of -s right there. The big thing is, where's that at here? Let's see it on here. I may have it on a different one or skipped it. The symbolic links will work across hard drives. So that is a huge thing. If you have like a lot of times in a production environment, you don't want to have all of your users, their home directory, on the same hard drive as the operating system, because if your users wind up filling up the hard drive with personal files, they crash the operating system. So you want to have at least that on a separate partition or a completely different drive. So if they do fill it up, then you just got a full hard drive, but your operating system is still running. So you couldn't do that if that was set up. You couldn't use hard links at all. So hard or symbolic links kind of helps us fix that problem right there. All right, so this will all help a little bit. This is the example directory that we're going to use, and we'll kind of work through the hard link and soft link. Let's see if I can make that go away right here. Okay, so here is a hard link. So this right here is the hard link that we have. So this is kind of the original contents that are on the disk right there. Now let's just say that we'll say .profile is the original file, and then we went and CD'd into temp right here, and then we created foo, but we created it as a hard link, which again points to that document. So if I come into here and I say, okay, I decided I don't want this, link that I created here, and get it, and I delete this right here. Is anything bad going to occur looking at this? Will I lose access to the file in any way? What'd you say? Only from temp. Perfect. I apologize, but this person only calls me in emergencies. Let me see. Hello? I got sick kids at home and I've got one kid coming back from a trip and they were making sure that they had a ride. All right, so now let's just go ahead and say that I didn't destroy, I decide I want to delete the original. What do y'all think? Do I have any problem here? Did I lose any data? No, perfect. So it doesn't matter. I can delete either one of those. And so long as one exists, now obviously here I have a problem, but it doesn't matter which one I delete because they are directly linked to that original contents. No problem. Now, let's look at this case. Here's my original right here. And then I CD into temp, I create foo, it creates a symbolic link to .profile. And then I later decide, I want to get rid of foo. Did I lose any data? Do I have any problem? Perfect. No. All right. Let's say now I come over here and I decide I'm going to delete .profile. Do I have a problem? Perfect. Yes, I have a big problem. This thing right here goes all red and gives me all kinds of errors. It's completely broken. It's no good. I have now lost that data right there. So there's give and takes on it. So just depends on you get a little bit of redundancy with that hard link. But again, it's one file to one file versus in this one, we can actually do a directory. In this case, it is a file right here, but you can use a directory. All right, so here's just some examples right there of creating a hard link. Again, it's just LN, the file that you're referencing, and then the destination right there. So this is the original file. You would create this other file called link file. And of course, this is actually putting them both in the present working directory. You know, if we did /home and then some name here, and then created the link file right there, we could do that. So therefore it's creating it in a completely different directory, or the better option may be you could CD into wherever or CD into home / whatever name, and then kind of create it backwards from there, which you would specify the path here to that original file right there. And then we have creating symbolic links, same thing. All you got to do is that -S right there. And then you will also note in here, you can easily tell from a symbolic and a hard link. So right here, the hard link, there's kind of nothing there. But when a symbolic link is there, you have this nice little pointer. And if file 1 was in a completely different directory, it would have kind of the full path specified to that file right there. So kind of easily, and they're actually in Bash, they're color coded as well. And then when we start talking about file permissions, kind of pay attention to that. That L right there means it's a link file as well. So you have several ways of kind of telling that, but we'll cover that later. Wow, I blew through that. What time is it? 11:26. Let's see here. I don't know if I want to move on to this. I don't think I want to. So I think we'll just call it here. And we'll pick up on this when we get back. Note that it's not going to show up in there. There is 2 homework assignments, but it's pretty much overall the permission, so we can't cover that. So just I'll try to remind you that next time it's not showing up, but it will show up in that module, a lab and an actual take-home assignment there. All right, y'all are good to go. I will see you on Thursday.